We are a not-for-profit group with a focus on restoring the environment and with a particular emphasis on wetlands. And we work across the agricultural regions, roughly between Adelaide and Melbourne. Also some staff based in Tasmania and some projects in New South Wales. And our work is funded by philanthropy, government grants, and we also offer our services out as consultants. That's how we sort of get by. And we are tax deductible gift recipients if you want to make a donation to us. And the Glenelg in our name does not refer to Glenelg Beach, it refers to the Glenelg River, which is the one that goes to sea down near the Victorian border, actually in Victoria, and that's sort of the geographic heartland of our geographic range. But tonight, yes, I'll be talking about the work we've been doing at Glen Shera Swamp. And it sounds like you've heard from Mark Backman before. That would have been right back near the beginning of our involvement with Glen Shera Swamp, when we were sort of coming up with options to restore the swamp. We're pretty much now at the other end. We've kind of done most of what can be done at Glen Shera in terms of hydrological restoration. So, yeah, you'll be able to compare. What are Fleurieu Peninsula swamps? You probably know them. They're these distinct communities that occur on the Fleurieu Peninsula where there's permanent groundwater generally, and they're characterised by having a real mixture of sedges, shrubs, ferns, and all these different forms of plants growing closely together, and are quite distinctive. They were listed as a critically endangered community under the federal EPBC Act in 2003. So they are groundwater dependent ecosystems, and this is a bit of a sort of model or diagram of sort of how lots of the Fleurieu Peninsula works from a hydrological perspective, where these hills are often old sand dunes that date right back. I'm not a geologist, but I think they go back something like 250 million odd years. So there'll be sand above and there'll be some kind of confining layer at depth. And so when the rain hits the sand, a fair portion of it infiltrates until it hits this confining layer, and then it starts to move laterally and hits a point lower down the valley where it starts to seep out of the ground. And that can be actually not necessarily in the bottom, but that can actually be up the slope a little bit, where you can see water seeping out of a hillside with a Fleurieu Peninsula swamp sort of clinging onto the side of a hill, which is unusual for a swamp. Swamps typically are basins of water that fill up and hold water, whereas these can actually be on a sloping piece of ground where there's permanent groundwater seeping out of a hillside. And often that permanently saturated ground is peat. Not always. So there's a photographic example of one down on the Fleurieu there, the swamp sort of at the bottom of the valley, and the hillsides would have been stringy bark previously that have been cleared, but the swamp remains. And this is an example of the types of impacts you see on these swamps, where a dam has been dug in the middle of the swamp. They're quite restricted geographically, so this map here shows pretty much the complete extent of Fleurieu swamps. See, there's quite a few of them down around the sort of Harrower area, and quite a few around Mount Compass, and that's about it. So originally they probably occupied about 2,000 hectares in total. Today it's around about 545 hectares in 77 swamps that you could classify as in relatively good condition. There would be more than that, but they're so degraded that they barely qualify as a swamp anymore. But they're mostly quite small, so the average size is 7 hectares. But they sort of punch above their weight for size. So a lot of the threatened species of the Fleurieu Peninsula area have some kind of association with fleuro swamps, including a lot of flora and fauna. And here's a couple of examples. Slaty leek orchid, named after Denzel Murfitt, which is nationally critically endangered, and the famous Mount Lofty Ranges southern emu wren, which does occur in different types of habitats, but certainly fleuro swamps are one of their strongholds. But they're not doing that well, is my understanding. They're declining. There's something like 150 left. I thought I'd show you some slides of some of the orchids that occur in Glen Shera Swamp. So these are, if I just go back, sorry, there are 34 species of orchids that live, or that are known to occur in Glen Shera Swamp or Stipiturus Conservation Park, and 15 of them have some kind of conservation rating. So I'm not going to give you a profile of each. I'll just flick through some photos for you to see. I'm sure you know more about them than I do. There's some of them, the vulnerables. Not all of these orchids are pure wetland specialists. A lot of them are more woodland specialists around the margins of the swamp. But there's some, let's see, it's a bit of a hot spot. And the mitras, some of those guys. So these are some of the non-threatened ones. And yeah. So it's a pretty good spot to go for a wander around. Orchid spotting. So, here I've listed some of the threats to swamps, and they're one of the usual culprits: clearance, land use, grazing, weeds, inappropriate fire regimes. But the ones that we at Glenelg Trust have been focused on are the hydrological issues, and in particular the legacy of historic drainage. So we've looked at a number of swamps, and every single swamp that we've looked at has drains cut through it from some agricultural activities in the past. Even the biggest and best and most intact examples of fleuro swamps have drains through them, to our knowledge. We haven't found one yet that doesn't. So that's what our focus has been. So here's Glen Shera. So the blue polygon is the mapped wetland, and the white line is actually the boundary of Stipiturus Conservation Park. So Glen Shera Swamp is actually bigger than Stipiturus Conservation Park. It goes partly onto this private property here, and I think the boundary between this parcel here and this parcel here comes roughly along here. So it's mostly one single landholder who has this bit here, and they've actually been very cooperative and have done really good things helping to restore and manage this portion of the swamp that's on their property. But also, of course, in the conservation park, there's been lots of work done. So this is the biggest and most intact Fleurieu Swamp. It's 40 hectares in size, and like most swamps, it's groundwater fed, but it also has this surface water inflow that comes in seasonally from a creek out to the east, and it flows in here, and I'll tell you a little bit more about that creek because it's been quite a focus for us. So these red lines here, there's actually 8.8 kilometres of drain cut through Glen Shera Swamp. So that's a 40 hectare swamp, 8.8 kilometres of drain. So they really had a good hard go at it, trying to dry it out, trying to convert it to improved pasture. But probably there was just so much groundwater in this particular area that they weren't successful. So that's why it still exists today. Right, so we've been involved, as I said, since around 2015. Well, did I say that? That's when Mark would have come to speak to you, I guess, last, around 2015. At that point, we came up with a range of steps or, different options to restore the swamp hydrologically. So the first one was to install a series of trial structures made out of sandbags, geofabric material. We used some volunteers from the Yakka group down there. And the idea here was to try and recreate the natural meandering course of the inflow creek that comes into Glen Shera in the winter, and try and re-divert the creek back into the swamp because it had actually been short-circuited. I might just go back a little bit. I know you're having trouble seeing the red line, but this is where the creek comes in, and historically it just came in and then flowed into the swamp, and that was it. What was done was the creek was actually turned into a drain, and the drain bypassed the swamp, bypassed this top end of the swamp anyway, and then dropped back down into here, but it continued on and off and out of the whole system. So our initial focus was to try and re-divert those seasonal flows back into the swamp. So the trial structures were part of that. The trial structures can be adjusted in time. So if we go out to the site during a flow event and we find that they're sitting a bit high and water's not going where we want it to, or there's too much water going where we don't want it to go, we can take some sandbags off and adjust them, or we can add more sandbags. So they're kind of good like that. You're not really committing to anything. It's a trial structure, but they do degrade through time. So that can't be the end result. It's not the permanent solution. So this is a digital topographic image of where we focused our works on the inflow creek. So the dark blue is the most low-lying ground, and the brown is the more elevated ground. So you can see that all the water was coming down this artificially excavated channel, but you can see that there's actually the remnants of a naturally meandering old creek line here. So we've tried to reinstate that, but importantly at this end, where the water was being taken away and bypassing the swamp, we've tried to re-divert it back up this old inflow point, which as you see ends blindly in the heart of the swamp. So this is a photo from 2017 when, for the first time, we're looking downstream here at one of our structures, and for the very first time in about 70 years, surface flows are heading back into the swamp, we've had to cut through the spoil mound. So when the drain was excavated, the spoil was placed alongside it, and we've cut through that to enable the water to get into the swamp. And this is an example of the kind of outcome we got with a re-engagement of this little natural meander at this location that may not have seen water for something like 70 years, and then we've got water back flowing through it again. And you start to see some biological impact straight away. So this is down towards the sort of western side of the swamp. All this wetter ground that we've created here has killed bracken. So bracken's not a wetland plant. It can't tolerate permanent inundation, but it was growing in the middle of Glen Shera Swamp because the swamp had been dried out so much by all these drains. So there's an adjustment phase where things like that are dying off, and then the original swamp vegetation is given a chance to come back. So another step in the process is to actually bring in small excavators and backfill some of the drains out the bed of the swamp. So here we have an excavator pushing that spoil mound back into the drain to recreate the natural surface. The spoil mounds are often quite distinctive because they're more elevated than the ground around them, and because of that they're drier, and so they're often covered in weeds. Things like, Yorkshire fog grass, blackberries, those sorts of things. So it's quite a pleasure to go along and push all that back in and pack it into the old drain and recreate the natural surface. And actually, you get this footprint, but it's quite temporary. And we have actually found that in the ground where we've scraped off the old spoil and pushed it back into the drain, that bare ground, rare plants have emerged. They've been buried under spoil for decades, and then somehow the disturbance of getting the spoil off, either their propagules have survived, or we're not quite sure, but rare things have popped up in those footprints. So this is the kind of theory of it. You've got a drain. The drain has lowered the groundwater level, so it's dried out the surface of the peat, which is a very, peat really only occurs in permanently wet ground. So once that peat becomes dry, it starts to degrade. The carbon that's stored in it starts to go into the atmosphere, and the vegetation that has grown on it, which has grown on it because it's permanently wet, can't tolerate it, and so these other things come in. So yeah, we just take that spoil and push it back in, and then we get groundwater recovery across the surface and rehydration of the peat. Here's a close-up of a footprint where some works have been recently done in 2017, and then 2 years later, pretty good recovery, and it's just a real mass recruitment of swampy shrubs, things like prickly tea tree and other things coming up. And then another step along the way is to go back to the structures and make them permanent, so bury them under spoil. So that's what we're doing here, a structure along the creek. Because in the creek itself, not only had a machine originally excavated a drain and placed the spoil alongside it, but then in the intervening years, that creek was carrying such high velocity flow that the creek eroded, the channel, the drain eroded a lot. So there's actually not enough material to completely backfill the drain anymore because the volume has increased so much. So in this case, you have to create a series of blocks along it. And in this creek environment, they also are likely to get overtopped by a high flow at times, so we're putting geofabric, erosion proofing stuff over the top of these works as we go. Here's just some photos. So this is down near the bottom of the swamp where a combination of drain backfilling and structures has been done. So this is what it looked like before we did any work, and this is really just a sea of Fleurius, weedy grasses, quite hard to get rid of. This is a short time after we'd done the first work, the first winter. In this area we created some shallow permanent inundation. Another year later, we're starting to see the Fleurius disappear and native sedges and things bounce back. So this is one of the things we love about doing swamp restoration work, is that you don't really need to do revegetation because all of the propagules are there waiting. You've just got to get the hydrology right, and then the native vegetation re-establishes itself. So no one had to go out and spray that Fleurius, it just died off, and in its place we now have a native sedge land, and this is what it looks like now. And in fact, when I was there in April, there's still water flowing out of the swamp at this location after this extended dry, which is really encouraging. So, you know, there's a concern, I guess, people might have, well, you know, you're actually increasing the wetted area of this swamp by restoring it. The total volume of water required to keep this whole swamp wet has increased as you've restored it, and yet, even in the height of this current drought, we've still got the whole thing saturated with surface water and water still coming out of it. So there's a phase where the swamp rehydrates, but then once it's resaturated, inflows and outflows sort of roughly return to what they were. So this is, back to the previous image, this one shows the green lines of the drains that we've backfilled, and the yellow triangles are the structures that we've put in place, and that's sort of the overall story. We haven't been able to backfill every single drain that we'd like out in the heart of the swamp up here, because it's actually so wet that if you send an excavator in there, you're likely to lose it. So we've just done as much as we can. There's pretty much, you know, nothing more to do from a hydrological perspective. We'd quite like to be able to fill this drain in. This is the main outlet drain that takes the water under Saffron's Road here and sends it down to Maiponga Reservoir, but that would require this land here all becoming part of it, going underwater, and at this point in time that's not on the agenda. This slide just shows some of our monitoring. So we've got the green lines are vegetation transects. So we've been measuring the vegetation, not as regularly as we probably should, but and then the yellow are water level loggers. Some of them are down in the groundwater, so we can measure how we've influenced the groundwater, and some of them are in surface water. And this slide here shows data from one of those loggers in the early years of the project. So it's a bit complex, this figure, but what the orange here shows is cumulative rainfall, so in millimetres for the year. So this is the year 2016. It was a wet year, if you remember, and the cumulative rainfall, I'm not quite sure where the gauge was for this, but anyway, is up there, and you can see, and this is time here from winter 2016 through till early winter 2019, Now the first phase of major drain backfilling and trial structures and whatnot happened here. So the blue line is the flow rate of water exiting the whole system downstream in megalitres per day. So in 2016, which was a wet year, we had this very, very spiky sort of hydrograph. And when the rain eased off, the flow rate dropped right down very low very quickly and stayed very low through the following summer. Then we do the work here, and the following year, even though we don't get quite as much rainfall, the flow rate, it still has this spiky look about it, but notice that the base flow, the very low rate of flow exiting the swamp the following summer is possibly a little bit higher than it was the year before. The year after that, another relatively dry year, but the whole curve started to look a bit smoother, and the flow rate in summer, what we call base flow, is actually starting to creep up. It's quite a bit higher here than it was back in 2016, despite 2016 having been a much wetter year. So the way we interpret this is basically Glen Shera Swamp is a massive sponge, and before we did the work it had big drains cut through it. The size of the sponge had been reduced by drainage. The sponge fills up in winter, it holds the water, and then it releases it slowly for the rest of the time through the dry months. So by restoring it, we've increased the size of the sponge, and therefore we've increased the rate of water that can flow out of it during the drier phase. So that's really important, not just for the swamp itself, but also for downstream, because that flow is keeping summer pools and things further downstream topped up. So this is the kind of landscape scale case for wetland restoration. So thank you very much. That's all I've got to say. I'm happy to take any questions you might have.
Is there an issue of hydrological becoming? I know it's not directly a hydrological issue, but I suppose they're an artifact of sedimentation. Is that a potential problem in the future?
Yeah.
Taking over the red beds and becoming dominant?
Yeah.
At the expense of other species?
Definitely. Typha and Phragmites both. And in this image actually, which in this image you can see the whole of Glen Shera Swamp, the private land in the foreground and the public land in the background underneath the thank you. But over here you can see a big patch, pale brown patch, that's Phragmites, and that is that had developed where the old bypass drain dropped back into the swamp here, and then it's just been expanding, and we've looked at aerial images that show how it has been expanding through time and actually taking over healthy swamp vegetation. So probably, as you say, was advantaged by the fact that the drain, as it came into this part of the swamp, was hitting slow water and depositing sediment there, and it took advantage. So it's something we have to be mindful of. Where we've now diverted that water back into the heart of the swamp, we have to be very mindful of that risk. Keep an eye on it. The other thing that ought to be done really is that we ought to try and get rid of this Phragmites. It's a big job, but it can be done. Because I don't know if anyone knows John Farger. He's got a property down near Yundi. It's got a Fleurieu Swamp on it, and it had a huge swathe of Phragmites, and he has single-handedly turned it back into diverse swampy vegetation. So it can be done. But yeah, it's a concern. It is something to keep an eye on.
Why is Phragmites considered a weed? It's a native plant?
Yeah, it's a native plant. I mean, it's not really you wouldn't classify it as a weed. It's a problematic native. Because it forms such a monoculture, it's an ecosystem engineer. So once it gets in, it deposits so much material, it captures so much sediment that it actually raises the ground. So then because the ground is more elevated, it doesn't get as wet, so it dries out the swamp, which suits itself, and it just becomes this feedback loop where the longer it's been there, the better hold it's got on the area. And it has its own, species that like to inhabit Phragmites, reed warblers and various things, but there's plenty of Phragmites around. There's not very much Fleurieu Peninsula swamp around. We need to try and make sure that it doesn't all go the way of becoming a Phragmites monoculture.
I know in Torrens, I've read accounts of Phragmites being quite extensive where the Torrens used to finish, until they dredged that area and made it, go out to sea.
Yeah. Yeah, it certainly has its place, absolutely, and it's can be really valuable habitat.
I was going to ask, did you have any resistance from the neighbours about filling in the creeks that were formed, or the drainages?
Not really, not in this case. It's Glen Shera Swamp's like in the bottom of a big bowl, so you don't get a backwater effect that floods them out. It's not like other places we work down in the southeast where the land falls a metre in 5 kilometres. So every little sandbag has a backwater effect that goes way back. No, it's quite different here. This is the landholder here this is private land, and it's the same property coming all the way down through here to here. So he's essentially donated all this land to the conservation cause. It's not on title or anything like that, but it's been fenced. The landscape board have put a lot of effort into weed management, and they have done some re-veg in this area, but you can kind of see the old footprints of the drains that we backfilled that are slowly disappearing. But the neighbours here have been excellent. Yeah.
Is fire management or burning part of the sort of management toolkit? For example, managing typhoon and Phragmites.
Yeah.
Or other biodiversity benefits.
Yeah, both.
Yeah.
So I mean, there's a prescribed burning program for the healthy parts of the swamp, and I couldn't tell you what all the details, but there's been 3 or 4 fires since we've been involved, since 2015, prescribed. And then one got into this Phragmites actually, and so it was bare ground for about a day, and then the Phragmites was 6 foot high again. But where John Farker has got rid of the Phragmites at Yundi, he has used fire. Fire combined with spraying and just lots of hard yakka.
Is it repeated burning, or burning again when it's young?
There's all sorts of strategies, but you're trying to deplete the below ground resource, right? So just get it to express its below ground resource above ground, and then get rid of that, and then keep going. Yeah, and fire can be useful in that.
How about the Stipiturus winds
Just in general, or in response to fire?
in response, since you've been involved?
Yeah.
Have you got numbers on what's happening to the population?
I'm not really up to speed on it, to be honest. But my understanding is that they're sort of hanging in there as well as anywhere else. Yeah. Yep. But, I mean, I don't think we could say hydrological restoration has led to an increase in the wren population. I don't think we could say that. No. But I think they're hanging in there at Glen Shera probably as well as anywhere else, which across the board is not great.
Hi Ben, I've done a fair bit of weed control work on the site. I think I've probably finished just before 16, doing blackberry and broom, and so yeah, a lot of those grains I'm quite familiar with.
Right.
Yeah, the last time I was there were a lot of kangaroo fences. Is that
yeah.
sort of integrated with the work that you're doing? And
loosely, we haven't been the drivers of that, but yes, nearly the entire reserve has a kangaroo-proof fence around it, and it's to give some of the re-veg a chance, because there has been a lot of re-veg. I think there's been 120,000 plants going to Stipiturus, but they're not so much in the swamp, they're on the high ground surrounding the swamp. So that's like, in this image, it's sort of up here. It's a bit hard to see, but it's some of the best looking revegetation I've ever seen. And that's partly because the kangaroos have been excluded, and partly because they planted into a sort of a bracken type area. So you slash the bracken back, you weaken that, then you plant high density, heathy, dry heathy type vegetation is what they put in. No trees, just this sort of dry heath. And then the re-veg grows and the bracken grows, and it's kind of weed-free re-veg, which is great to see, and it seems to be doing really well.
so the swamp has not had much in the way of eucalypts back originally?
It probably, I mean, it's still got plenty, not in the swamp itself, no. The creek line has, I think, the swamp gums and things along it, and then there would have been more stringy bark amongst that sort of higher ground, but quite deliberately the strategy has been to create the dense heathy vegetation that the emu wrens like. So they like it in the swamp, but they also like it up on the dry ground. The more trees you have, the less dense heath you have. So they've just deliberately focused on the heath, because the heath supports a whole range of the really sort of threatened birds of the Fleurieu Peninsula, like the wrens and some of the other various other species, beautiful firetails, I think, and others like that. Yeah.
Yeah, so when I was involved, a lot of the focus was on Alocasia robusta, trying to get that re-established.
Yeah.
I remember finding some seedlings one time, and that was just before a fire escaped from the neighbour and burnt the whole area, so those seedlings didn't survive.
Yeah. There's a bit of it in there, definitely. Yeah. Yep.
Anybody else? Thank you very much.
You're welcome. Thanks for having me.